Yep. Okay. This is SolMate.
Hi, we're Team 20 SolMate. SolMate is an autonomous sailboat bailing solution. The goal of our product is to take away the monotony of going to manually bail out your boat and/or the fear that your boat may get swamped. Our customer is Professor Mark Hornstein, and our mission is to provide a status reporting system powered by a solar panel that can give our customer peace of mind from far away. And additionally, this system is important to more than just sailboat owners. It has applications in basements and anywhere that a flooding problem or swamping problem can occur. And the current state of the project is it is finished and it meets the customer's requirements and it functions very well.
So here's a picture of our full project. Right here is the solar panel, and we have the battery right here. This is the enclosure with the PCB and the cellular modules right here, and our float switch is right here. And it goes to the pump, which is not in the picture yet.
So the major components is a belt pump running at 500 gallons per hour, which is fast enough to pump the water out in time. A rechargeable battery with 12 amp and 12 AH, and a solar panel which has a built-in block diode to prevent overcharging and can output up to 6 watts of power. Some 5 magnetic flow switch. They are waterproof and corrosion proof. And MSP430 is our microcontroller, and a GSM cell module for the SMS communication.
So for personal roles, I'm Scott. I personally worked with the circuitry and the hardware design of the project. I basically worked on all the intermediary parts to communicate information from the hardware peripherals to the MSP430. I also worked on all the PCB design and the PCB assembly.
I'm Mark. So I'm responsible for the flow switch array, which aka is the water depth sensing system. It basically consists of one PVC tube and 5 flow switches. And the flow switches are connected to the microcontroller through the wires that run in the middle, through the middle of the tube. And so it provides us 5 levels of water depth, and all the components are both waterproof and corrosion proof.
I'm Peter. I was responsible for the cellular module, and along with Patrick, the microcontroller code. What I worked on in the project was connecting the microcontroller and the cellular module together so we can send and receive text. I also worked on the code for the bilge pump and solar panel control. And lastly, the notifications and status reports to the owner.
Hi, I'm Patrick. I was responsible for programming the microcontroller along with Peter. Some of the notable things I've done is I made code to update and store the user's phone number in flash memory. I wrote a function to read the water level through the float switches. And I created a function that was able to detect if any of the float switches were malfunctioning.
Hi, I'm Paulina. My main responsibility was the enclosure and sealing the components of the PCB and the cellular module. So I chose a waterproof enclosure that allowed simple access for the wires to and from the electrical components. And then I also sealed the box so that it wouldn't be affected by the saline environment.
Oh. And so according to our customer, his boat's actually currently still in winter storage. It won't come out until mid-May. Therefore, customer installation can't really be done until late May or early June. However, Professor Ornstein has come and checked on the final state of our project, and he was satisfied with the functionality.
So, in conclusion, this project sort of has lasting implications in like smartly using solar energy or any green energy for that matter, and it also shows how we can use data to stay in touch with high maintenance products like a sailboat, or a product that you really care about. So, so it's all about keeping the customer informed with data. And once again, thank you to all of the ECE staff for helping us with this project.
Is there any sort of database to store maybe history of pumping or frequency of pumping or any sort of like analytics about it? Like any sort of cloud interface to track all this?
No.
Was that choice made by the customer or was that?
We were sort of concerned mainly with providing the very basic functionality. That was sort of what our customer was most concerned about. He just wanted a product that met his needs, and I don't think I'm sure that would be useful, but I don't think it was foremost in our minds for the product.
How long can it run when the battery's fully charged?
So it can run for 6 hours, so that if you do the math, 6 hours, 500 gallons per hour, that's a lot of water. It can pump out the keel of the sailboat in a matter of like 10 minutes or so.
And what's standby time? It's just pumping.
Incredibly long. It's like the MSP 430 is such a low power using microprocessor, and the battery is so high capacity that we didn't really calculate that.
Can you describe to me how the GSM module is connected? Is that on the PCB or?
Yeah, it's connected from a PCB to another board. But Peter, you want to go more into that?
Sure. Right now it's connected with wires from a header on the PCB, and that goes in the cell module.
And it's through UART, right?
Through UART. They communicate with UART serial.
How heavy is the device, and where do you plan on putting it in the boat?
I guess it has different parts have different. Okay, sorry, I didn't answer your first question. How heavy it is? The battery is 10 pounds, probably 10 pounds. The rest of it is light and can go wherever. So about the location, the battery and the electronics go in the cabin area where it's safer, and the solar panel goes outside, and the pump goes in the bilge area, and the float switches are also in the bilge area.
Would you be able to make it small? So you said it can last for 6 hours, but you might not need it to last for 6 hours. In the case where you just want to bail out your boat for the day and have it charge again, would you be able to make it lighter? And if you wanted to make it for like a smaller boat for less time?
Yeah, you'd probably end up using a smaller pump for that case, and those would have a lower current draw, and so you probably need a lower capacity battery too. So that's definitely something. And the whole system is modular. We didn't really talk about that, but you can use any 12-volt battery, any baler, and any solar panel, providing they also are like safe to use with the system. Okay.
Is it entirely electrically isolated? Grounding issues and things like that? Not a big deal on both.
Yeah, it's all isolated. Yep.
Can you talk about this decision to go with custom float switches? And I assume it's a custom pump as opposed to like
Well, they are off the shelf, but the peripheral for the flow switches that we made is we didn't make the flow switches ourselves, and we didn't make the pump ourselves. Those are off the shelf, but we made modifications such as the rod with all of the flow switches attached.
And what was the choice to go with discrete flow switches as opposed to sort of a continuous depth analysis?
So in our original design, we used the chip, a sensor like this small. It's continuous and it's electronic, purely digital. But then we discovered that it cannot withstand seawater environment. It will be corrupted instantly, immediately. So, so we then switched back to the flow switch choice because the flow switch they are sealed out of the box, and we don't have to worry about the corrosion problem because it's made of plastic.
And it's also cheaper and lower power than using digital continuous sensors. It also we didn't need incredibly high resolution for the data, just a relative sort of reading.
Is there any sort of configuration, like I want to pump at the lowest level or the highest level?
In the current state, that's not in our project, but it's certainly something we could implement very easily.
Do you have any logic for dealing with failures in the components so that the customer would know if there's a problem?
Yes, well, for the float switches, we can, so I wrote code to tell if a float switch, or if a reading is showing that the water level's here, but a float switch is off below it, then you know that there's an erroneous float switch, and so it reports that to the customer. So that way they can know before it's too late if the system isn't working properly.
Yeah.
Is there any sort of like overcurrent protection or anything like that? So if the pump gets shorted out, then we'll tell you that the pump is shorted out, they're not actually running it, or you can just protect it from the battery?
Yeah, it should. There is protection from that. It's pretty much isolated from and the microcontroller controls whether the baler is connected to the battery. So, and they're in separate modules, sort of, so they don't really interfere with each other. And then also, I believe there's programming in place. So, say the baler is blocked or something by some sediment or debris. If it's running for a certain amount of time and there's no water level going down, the microprocessor knows that.
Okay, thank you.